Okay, we can combine two sets together. Okay, just like the normal algebra. Okay, so the tools, the rules, okay, for those combinations of two sets, so we call the set operations. We're going to be looking at union, intersection, complements, difference, and symmetric difference. Okay, so the first one, union. Okay, for union is the combinations of two sets. If we have uh, let's A, let's have let's imagine set of 1, 3, 5. Let set B be set of 2, 4, 6, 7. So the union has this notation. This is symbol is denoted by U, A union B, A union B. So we use U for the symbol for union, okay, which will be combinations of elements in A and elements in B. And that will be equal to what? Set of 1, arranged in ascending order, 2, 3, 4, 5, 6, 7. So that's that on the union. Okay. For in this case, we are having two sets. And don't forget, set is written in capital letter. Set A, this is set B. It must be written in capital letter. And this must start, this bracket must start before you must start here and must end here. And what you have is inside that bracket is called the element of the set. For set A, the element of the set is 1, 3, 5. For set B, the element of the set is 2, 4, 6, 7. So that's that on union. You can write in symbol notation that X such that X is a member of A, or X is a member of what? Of B. That's the case of two sets. Let's go to intersection. Intersection is the combinations of all the elements in set A and B. And it has this notation. That's N. We are having two sets, set A and set B. So the notation for intersection is N. So A intersects B. Okay, so A intersects B in set notation implies that X such that X is a member of A, and at the same time, X also is a member of B. So we use AND for intersection, we use OR for union. Okay. Let's see example for intersection. If set A is 1, 2, is a set of the elements 1, 2, 3, 5, 6, 7. Okay, and set B is 3, 5, 6. The intersection is the element you can find in A, and at the same time, you can find it in what? In B. So that's the intersection. 3 is here, it's also here. 5 is here, 5 is also here. 6 is here, 6 is also here. So the intersection A intersect B is what? 3, 5, 6. Set of what? 3, 5, 6. Which is equal to what? Is equal to B. Is equal to set B. So that's that on union, and intersection. Send your comments, send your question, subscribe to the channel. Then the next one, the third one, is a complement. Okay, is a complement, and it has this symbol. So that you use prime, a prime, or a what to power c. So this is symbol for what, for complements. But one thing we must note in complements, you must have your universal sets. Okay, let's have let's the universal set be what, maybe elements 1, 2, 3 set of these up to 10. This is 1 to 10. Let's A be equal to 3, 5, 6, 7. Okay, so the A complement is equal to the notation, the set notation for A complement is X such that X is a member of what? Of universal sets. X is a member of universal sets, but X does not belong to what? It does not belong to A. It's a member of universal sets, but it does not belong to A. So what we are doing in this case is just that. Don't forget what we have here. This is 3, 4, 5, up to 10. So you remove all this one, 3, then the 4. Okay, 4 is not here. 5, you remove it from that for the universal sets. Let me finish this one. This one means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the meaning of these omitted values. So some values are omitted here up to 10. So 3, remove it from the universal set. 5, remove it from here. 6, remove it from here. 7, remove it from here. So the remaining elements in the universal set is called the complements. And that will be what? That will be 1, 2, 4, 8, 9, 10. That's why we say that X belongs to universal sets, but it does not belong to what? It does not belong to A. So that's that on the complements. So the B complements, very simple. Remove all these elements from the universal sets. 2 is there, cancel out. 3 is there, cancel out. 4 is there, cancel out. So the remaining element is what? In the universal set is now 1, 5, 6. So that's your what? That's your B complements. So it means that B complements will be what? X such that X belong to universal sets, okay, but X does not belong to what? Does not belong to B. So that's the case. So this is our answer in this case. Let's go to difference now. Welcome on board. Please subscribe so that you can forward your question. Okay, you can forward your question. You can also make comments and B. Okay, so difference is just A minus B. Okay, that's the difference. So imagine you have your A as what? As 1, 2, 4, 6, 8, 9, 10. Okay, then you have your B as what? As 4, 6, 8. That's your B. So what you are doing is that A minus B. You are removing this element of B from A. So this one strike out. This one also. This one also. So what left is your A minus B. So A minus B is equal to what? A minus B is equal to 1, 4, 9, 10. So that's that on A minus B. Okay? And this implies that um, for A minus B, the notation is this, S such that X belong to A, but X does not belong to what? Does not belong to B. So that's that on the difference. Okay, let's take one more questions on difference. Question 2. Assuming your set A is this is this. We have that. Then your set B. Let's assume let's have 8, 10, 11. Okay. So A minus B will be equal to what? Remove the element of B from A. 8 is there, 8 is there, 10 is there, 10 is there, 11 is there, 11 is there. So you have what? 1, 2, 12. That's the A minus B. Okay? That's the A minus B. Then finally, we go to symmetric difference. And after that, we now take a question properly. We're dealing with two sets for set A and B. Okay? The symmetric difference as the symbol is data. Okay? That's a symbol for symmetric difference. Okay? And that will be equal to, it has a formula. That's A union B minus what? A intersect B. So that's the formula for symmetric difference. Okay? Set A and set B. So this is notation for symmetric difference. So the first thing you do is to get the A union B. A union B will be combinations of the two sets. And that'll be 1, 2, 3, 4, 5, 6, 8, 10, 12. That's your A union B. What of the intersection? Is there any common element between A and B? Yes. One is there, one is here, one is there. These are common elements. Okay? So the A intersect B is 1. So now find the symmetrical difference between the two sets A and B. So that will be equal to what? That's equal to what? That's equal to, just remove this one from here. Then you have what? You have 2, 3, 4, 5, 6, 8, 10, and then 12. So that's that on your symmetrical difference. So it's, we can say A delta B is equal to, as in set notation, X such that X say belong to what? Belong to A union B. Okay, X belong to A union B. Okay, X does not belong to what? Does not belong to A intersect what? Intersect B. So that's that on that case. Let's now go to question proper. Let's go to question, standard question, and solve. Welcome on board. Welcome, welcome, welcome. If you're new, please subscribe so I can type your questions. And also you can get notified anytime I'm online. I'm doing anytime I'm doing live, or anytime I upload a new video. For those that are already subscribed, thank you for coming again. Keep typing your questions, forward your comments, your contributions. Thank you for doing that. What we have here is U, which is the universal set, okay, equal to set of x such that 0 less x less or equal to 25, and s belong to positive integer, okay. Then we have a is equal to what? Y such that y is equal to what? 2x, and x belong to positive integer, and it goes on like that. So z for b, z is equal to what? 2x plus 1, x belongs to positive integer, k equal to what? 3x, and then x belongs to positive integer. I for d, for set d, I is equal to 5x plus 1, x belongs to positive integer, where a, b, c, and d, a, b, c, and d are subsets of what? Of universal sets. List the elements of set A, B, C, and D. Find A union B, A union C, A union D, and so on and so forth. So let's quickly look at let's list the elements. For the first one, for the universal sets, we have 0 less x, but x is less or equal to 25. And the positive integer, if 0 less x, that means x is what? More than 0. So the value will start from 1, 2, 3, 4, 5, 6, and then it goes on like that until what? Until 24. Less than or equal to what? 25. So 24 and then 25. So that's your universal set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, until 25. Less than or equal to 25. That's your A. That's your universal set. For set A, y such that y is equal to 2x, and x belongs to positive integer. So the subset means that where A, B, C are subset of U, it means that all these sets, they must be what? They must be found in universal sets. They must be in that range of universal sets. They are subsets. Okay? Subsets. So for when x is equal to 1, yeah, when x is equal to 1, this is what? Y will be equal to what? 2 times 1. So we have 2. When it's 2, 2 times 2, we have 4. When is that 3, that's 6. So it goes on like that. 8, 10, 12, 14, 16, 18, 20, 22, and then 24. For 24, that means your x is what? Is 12. Okay. So the next value, x is equal to 13. If you do that, it will be what? It will be outside that range of the universal sets. So we stop at 12 and get 24. Okay. So that's A. That's A. And next start from 1. Okay. Let's start from 1. So 2 times 1 plus 1. That's what? That's 3. For 2, 2 times 2 plus 1. That's 5. For 3, that's a 7. So it goes on like that. It's forming odd number. 11, 13, 15, 17, 19, 21, 23, and then 20. When then is 12, that's 2 times 12 plus 1. That's what? That's 25. So that's a B. That's set B. For set C, we have k is equal to what? 3x. Your x start from 1. Okay. So that'll be 3 times 1 times 2. That's 6. times 3, 9, times 4, 12, 5, 6. 3 times 6, that's a, uh, 3 times 6, that's 18. That's 18. Times 7, 21, and then 24. So, so that's that. Then I is equal to 5x plus 1, and x starts from 1 here. Okay, so 5 times 1 plus 1, that's 6. That's 6. Then 2, 5 times 2 plus 1, that's 11. Times 3 plus 1, that's 16. Times 4 plus 1, that's 21. So that's where it's going to stop. If you use 5, it's going to be outside that range of universal sets. So that's the all the element of those are set A, B, C, and D. So that one is gotten. So let's now find A union B now. A. Where's my A? My A is okay. Okay, this is my B. So now combine set A and set B together. Combinations of the element in B and element in A. So that'll be equal to Q. That'll be Q. 3, 4, 5, 6, and 7. Okay, 8, 10. Okay, I skipped 9. There's 9 here. So 9, 10, 11, 11, 11, 12, 13, 13, 14, 14 is there, 15, 15, then 16, 17, 17, 18, 19, 20, 21, 21, 22, 22, 23, 24, and then 25. So that's the what do you call it? That's the A union B. That's A union B. Okay, that's A union B for that case. Okay, let's find that A union C. Let me see what you get for A union C in the comment section for A union C. So let me go to A union D. A union D now. Okay, welcome on board. Subscribe to the channel so I can forward your question. Do it now. Like to make it interactive, and the communication will be in two-way. Subscribe and type your questions. Let's do A union D. A union D. We have the D. D is what? We have D as what? 6, 11, 15, that's 16, 4, that's 21. That's our D. So let's now get A union D. A union D. My A is what? My A is even number 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. That's my A. So combine the union together. A union D. A union D. Combine them together. A union D. That will be equal to set of Q, 4, 6, okay, 8, then 10, 11 is here, 11, 12, 14, 16, 16, and then uh, 16, 18, uh, 18, after 18, 20, 20, 20, 20, 21, 22, 24. That's your A union D. B union C, let me see it in your comment section. Type it on your comment section, and B union D also type it on your comment section. Okay. So I'll just go to the 51. Also do this one on your comment section, C union D. So let's go to A intersect B. A and B is just the common element in empty set for A intersect B. There's no common elements. The set B is set B is odd number. Set A is what? Even number. So nothing is common there. So it's empty set, or you can write it this way. So that's correct. Can we get A intersect C? For C, we also have odd number, okay, and we are combining with what? Okay, for C, we have this value, okay. So what is common there? 6 is there. 11 is there. Do we have 11 here? No. No. 16 is there. 16 is there. 21 is there. 21 is not here. So this is a intersect B. So that's that on this episode. So we are going to continue hopefully tomorrow by the grace of God to solve more questions on symmetric difference, okay, and then difference A minus B. My next video, okay, by the grace of God. So thank you for joining me. Thank you so much. See you again tomorrow by the grace of God. So please subscribe to the channel, type your comments, share the link of this video on all your social media platforms. Thank you for doing that.